Graphing a linear equation using two coordinate points. Well, we all know the shortest distance between 2 points is a straight line. We know that probably from crossing a street and trying to get somewhere faster. If we're given 2 points, we can actually draw the solution line between them. So if we're given the point -2, 4, we can plot that, -2 on the x-axis and up 4 on the y-axis. And 3, 5, -5, we can go over 3 on the x-axis and down to -5 on the y-axis. When we have those 2 points, we can connect them with a straight line. There are lots of different solutions to the line that contains both of these points. In fact, infinitely many. But oftentimes we're not just given 2 coordinate points and asked to draw the line. We're often given equations. So let's take a look at that. So say we have the equation x plus y equals 7. Now when we have that equation, we know that's a linear equation and it has infinitely many solutions. All of the solutions on that line. In fact, any x that we choose, we can find a y that will help us satisfy that. So that's exactly what we're going to do. We're just going to choose an x value and see if we can come up with a y value. We can also choose a y value and come up with the x value that matches in order to make that equation true. So if we look at x equals 0, I like to choose 0 because it often makes things easier to calculate. If we look at x equals 0, we're going to substitute a 0 in for the x. So 0 plus y equals 7, and we can solve for y right there. So if 0 plus y equals 7, y must be a 7. We can also choose another value for x. Let's say x equals 3. And if we choose a value for x right there, we substitute the 3 in for the x. 3 plus y equals 7. We subtract 3 from both sides of that equation, and y is equal to 4. Now let's take a look at choosing a y value. In some cases, it's easier to choose x values to find the y coordinate, but sometimes it's easier to choose y values and find the x coordinate. In this case, it's equally easy to do both, so I want to show you how that works. Let's choose for y a -2 and figure out what x is going to be. So x plus a -2 equals 7. We're going to add 2 to both sides of that equation, and we have x is equal to 9. Now we have 3 different solutions to our equation. We actually only need 2 in order to graph a line, but we've got our 3 right here. Let's try another one just because it's kind of interesting. It's a decimal, it's not an integer. Now the solutions to our linear equation include all real numbers, not just integers. So I want to show you what a fractional piece, a rational number in this would look like. So if we have x is equal to 3.5, we can substitute that in for x. 3.5 plus y equals 7. Subtract 3.5 from both sides, and we have y is also equal to 3.5. Now using these solutions, we can create what's called a t-chart, and that helps us to graph some points. So let's take a look at our t-chart. When we have x equals 0, when x is equal to 0, y is equal to 7, so I can include that there. When x is equal to 3, y is equal to 4, put a 4 right here. When y is equal to -2, that's what we plugged in there, we found that x is equal to 9. And when x is equal to 3.5, y is also equal to 3.5. Now we've got 4 coordinate points, and we can actually graph this line. So here are our coordinate points again, and I wrote them as coordinate points. 0, 7, 3, 4, the x coordinate first, the y coordinate second, 9, -2, and 3.5, 3.5. Now really we only need 2 values to graph. I'm choosing the ones that are furthest away to give me kind of a wide area to draw my line. So I chose 0, 7, and I also chose 9, -2. Now when I connect those, all of these other solutions I came up with are also on this line. So if we look at 3, 4, over 3, up 4, and we have that on there. And we also have 3.5, 3.5, over 3.5, up 3.5, and there we have another solution. It's got infinitely many solutions, but we only need 2 points in order to graph that line. Let's take a look at another example. Negative 2x plus y is equal to 6. And again, I'm going to choose some values for x right here. I'm going to choose 0 again because I like that for my calculations. So instead of x right here, I'm going to substitute as 0 and figure out what y is equal to. So negative 2 times 0 plus y is equal to 6. Well, negative 2 times 0 I know is 0. 0 plus y equals 6, and so y is equal to 6. Now I'm going to try another value for x. I'm going to try a negative value. It's often good to leave about 2, at least 2 in between your values, because otherwise your dots are very close together and it makes it more difficult to graph. So x is equal to negative 2. I'm going to substitute a negative 2 in for that x. Negative 2 times negative 2 plus y is equal to 6. And so I have negative 2 times negative 2, which is a 4, plus y equals 6. I subtract 4 from both sides in order to solve for my y. And I have y is equal to 2. Now we can again choose a value for y and see what x equals if we'd like to. It makes it a little more difficult when you have a multiplier in front of that x because you have a possibility of getting a fraction, but you can still do it. So y equals 0. And when we substitute a 0 in for y, we have negative 2x plus 0 equals 6. And we have adding 0 right there, we just have negative 2x, and that's equal to 6. Divide both sides by a negative 2, and that goes in evenly, so we won't have a fractional answer. And that is x equals negative 3. So when y equals 0, x is a negative 3. And now we can again do our t-chart. Using this, we've got 3 points on there. Remember, we really only need 2 points. That third point's going to be like a checkpoint. So when x is equal to 0, y equals 6. When x is equal to negative 2, y is equal to 2. And when y is equal to 0, x is equal to negative 3. Now we have our t-chart. We can do our coordinate points, and we can graph our line. So here's our t-chart again, and we've got our coordinate points 0, 6, negative 2, 2, and 3, 0. I'm going to use negative 3, 0. Sorry about that. I'm going to use negative 3, 0, and 0, 6. I'm going to use this as my checkpoint. So I'm going to plot my point negative 3, 0, my point 0, 6, and I'm going to connect it. This negative 2, 2 is also a solution to this, as are all of these numbers in between. If I go over negative 2 and up 2, there it is on my graph, and that is a solution as well. Problem y equals negative 3x plus 4. Again, I'm going to choose some values for x, and in this case, it's easier to choose my values for x because I have y solved in terms of x. So if I plug something in for x, I can calculate y quite easily because I have no multipliers in front of y. So instead of choosing a value for y this time, I'm just going to choose my values for x. So I have x is equal to 0 because that's my favorite one to choose. Y equals negative 3 times 0 plus 4. Negative 3 times 0 is 0 plus 4, and I have a y equals 4. If I plug in a 3, I have y is equal to negative 3 times 3 plus 4. Negative 3 times 3 is negative 9. Negative 9 plus 4, and I have y equals negative 5. I'm going to choose one more point just as a checkpoint to make sure I didn't goof up. That's a great way to do that on a test, to make sure you didn't graph the wrong line or do your calculations incorrectly. I'm going to choose x is equal to negative 1. So instead of the x, I'm going to put in negative 1. Negative 3 times negative 1 plus 4. Negative 3 times negative 1 is going to give me a 3. 3 plus 4 is going to give me a 7. And again, I can do my t-chart. I have my coordinate points 0, 4, 3, negative 5, and negative 1, 7. I can plot 2 of those points on here. I plotted negative 1, 7 and 0, 4, and I drew my line in there, and I can use my third point as a checkpoint. And my checkpoint is going to be 3, negative 5. So I go over 3, and I go down, negative 5, and yep, it's on the graph. That's my checkpoint, and I have graphed that line.